So we're told the thing that can fluctuate is the distance from the shorter pole to wherever the two wires are going to meet. So x could be 20 feet, and then this would be 40. X could be 10 feet, this would be 50. So we get to choose where to put that, and we want to choose it so that these values are minimized. So we need to create an equation for the length of both of these wires in terms of our one variable x. And since these are right triangles, that seems to imply the Pythagorean theorem. But what's this side over here? Well, if the whole thing is 60, this side over here has to be 60 minus x. That way the two sides would add up to be the full 60 feet. Now we can use the Pythagorean theorem to write out the third side, the hypotenuse in each of these in terms of x. So we'll call it c squared, that equals a squared plus b squared. And we just need to take a square root of both sides. We'll ignore the negative possibility. So this is the square root of 400 plus x squared. And then over here, same thing. We have c squared equals a squared plus b squared. So we'll take a square root of both sides. I've done too many questions today. I don't know what 440 squared is off the top of my head. Probably should though, huh? If I'm a math teacher. Then this is 60 minus x squared. Okay, so we've got both of them now in terms of x. And now we want to minimize this distance. So the function we're really concerned about is the length of these wires. One wire is the square root of 400 plus x squared, and the other wire is the square root of 1600 plus 60 minus x squared. So to minimize or maximize, we take a derivative. So this square root is a 1/2 power. The 1/2 comes down and multiplies. And then the 1/2 power gets reduced by 1. And then over here you take a derivative, so the 1/2 comes down. So 1600 plus, oh, this one's going to need, oh shoot, you know what, I committed a cardinal sin. The chain rule, right? I took a derivative of the outermost function, but then the derivative of the innermost function isn't 1, it's 2x, so I need to multiply this by 2x. Maybe it's good I make a mistake in a video, I don't know, so students remember to look for it too, but sorry about that. The 1/2 on this next one comes down because we're taking a derivative. Glad I caught it instead of having to redo that whole part. And now chain rule, I'm not going to forget it this time. The derivative of the innermost function. So this 2 comes down and multiplies, gets reduced by 1, but then the derivative of the next innermost function is -1. So the derivative of the innermost function is, I'm running out of room, it's 2 times 60 minus x, now to the first power, and then we multiply it by -1. Okay, so we want to set this derivative equal to 0 to maximize or minimize. Then I've got a -1/2 power, so I'm going to make that positive. And while we're at it, 1/2 times 2 cancels out. So I've got x in the numerator. And then this is back to a square root of 400 plus x squared in the denominator. And then over here, this is a -1 times 2, so that's a -2. And then times 1/2, so we're going to make that be a negative, and then 1/2 and the 2 cancel out. So we took care of that negative that's over there too. And then that's a -1/2 power, so we'll make that positive by putting the square root in the denominator. And then in the numerator we have 60 minus x. So cancels everything else out. Okay, getting closer. The next step I'd do is multiply everything by one of the denominators to make that cancel out. So multiply everything by square root of 400 plus x squared. So that times 0 is 0, so that's nice. And that times that cancels out the denominator. And then this times this is not nice. That's why I hesitated. because what if we expanded this? Here, maybe, no, that's not going to be easier. I was thinking of a way of trying to get nicer common denominators, but I don't think it's worth even trying. So here's the numerator, but I'm multiplying it by this square root of 400 plus x squared. And then this part had its denominator canceled, but this denominator did not cancel yet. So I actually kept going with this problem, and I dropped something somewhere when I solved, and so I have to restart the video, but I think I might have found an easier way to do this. Let's just add this term to both sides. Hopefully I won't drop anything the second attempt here, because we're going to be able to just square both sides as it is. We have a bunch of radicals. We want to get rid of those. So we can square both sides right now. If you square this and square this, it's a balanced step. And if we do that, it's going to get rid of the radicals. We're just going to have 60 minus x squared in the numerator. And then this square root is being squared, so that's 400 plus x squared all over 1,600 plus 60 minus x squared, and that equals x squared. Yeah, so I guess I gotta get a new set for the whiteboard, get reset. One of those problems where they have multiple whiteboards that pull down on top of each other in those lecture halls. Because now if I'm trying to get x by itself, I have to get it out of the denominator, so I'm going to multiply both sides by that 1,600. Thinking here. I guess we just got to expand these. If you do 60 minus x times itself, you should get 3,600 minus 120x plus x squared. And if we distribute that x squared, we get 1,600x squared plus x squared times this same thing, which is this over here, right? So that's 3,600 minus 120x plus x squared. Man, to combine like terms, I think we just got to multiply these parentheses together. This stinks, huh? Maybe they could use smaller numbers, but it still would take a lot of steps. It's a tough equation. 1,440,000. I multiply these two, and then we got to multiply this. That's 48,000 minus 48,000x. Then plus 400x squared. Still not done with that left side. It's still going to multiply everything by x squared, so that's 3,600x squared minus 120x to the third plus x to the fourth. That's the left side. So before I even copy the right side, let's clean this up. X squareds can add up to make 4,000x. Here, leading highest power first. So x to the fourth. We've got no other x to the thirds. 400x squared plus 3,600x squared, that's 4,000x squared minus 48,000x plus 1,440,000. And then that equals this over here. We got 1,600x squared plus 3,600x squared minus 120x to the third. Maybe this wasn't easier. Plus x to the fourth. Okay, well, I see one thing that can help us. Subtract x to the fourth from both sides. Add 120 x to the third to both sides. This is going to make 5,000. Oh, that doesn't quite check out, does it? Did I add something wrong over here? No, that's 4,000x squared. Okay, so this step is correct up to this point, but I had to stop the video again because something else got lost. But we can subtract x to the fourth from both sides. You can add 120x to the third to both sides. Let's see, so over here we got, oh, I know what I did. Okay, 1,600x squared plus 3,600x squared. And that's 5,200x squared on the right. And we got to subtract 4,000x squared from both sides. So we get 1,200x squared over here. When we subtract that from both sides, add this to both sides, you get 48,000x. And then subtract this from both sides, so you get 1.44 million. And you can factor out 1,000. Maybe here, can they all be divided by 1,440? All be divided by 1,200. They can. Okay, so we can divide everything by 1,200. We can factor that out. So 48,000 divided by 1,200. It's 40. And then we got 1,440,000 divided by 1,200. So that's, oops, that's a minus. It's a minus, what is it? 1,200. Okay, so to finish solving, we've set this equal to 0. So you want to find two numbers. If you want to factor it, you want to find two numbers and multiply by negative 1,200, but add to be 40. I think that's x minus 20 and x minus 20. No. Add to be positive 40. Shoot. What was I thinking? Here, let's do 1,200 divided by 20. That's 60. So, sorry, this one should be plus 60. There, that's two numbers that multiply to be negative 1,200, but add up to be 40. So we'll ignore the negative answer. We got x equals 20 as the correct answer. So I forgot what the original question was, but x is 20. That's the length, I think, from the shorter pole to the longer pole.